Hello, and welcome to another exciting episode of Cooking with Unity. I'm your host, Max Moreau, and with me is my co-host, Philip Wilson.
I'm a co-hope.
Co-hope, yeah.
Yes.
You are our only co-hope.
Help me, Obi-Wan Kenobi. You're our only co-hope.
So we're basically done with Star Fox, so we're going to be starting a new project. I have heard some people that want to see us do a title screen at some point, and I may do a little title screen episode at some point in the future, but it won't be a main episode. So let's get to my computer screen. Where is this thing? So today we're going to be doing kind of a 3D take on an old concept of artillery, where basically you choose an angle and a power and you try and hit another person elsewhere. It's been redone millions of times. It's been known as worms, it's been known as gorilla, it's been known as castles. There's probably 30 different versions that are called castles.
Yeah,
there's Scorched Earth is another one if you remember yesteryear. And when I say yesteryear, I mean yester decade.
By gorilla, are you talking about the
QBASIC one?
The
bananas.
The banana and the gorilla?
Yeah, that's what I'm talking about. So, as you'll see, my interface is not how it's usually laid out, because this is actually how it looks when you install Unity currently. And I wanted to start with this just so that we can get it to the layout that I usually use and am fast in. Remember, if you have your own flows, feel free to experiment with this stuff, but I'm going to be setting this up sort of so that it's what we're used to. So, first of all, the layout that mine is based on is wide, so I switched to wide here in the layout, and you'll see everything kind of move around a little bit. And I don't like this dual pane project tab thing, so I usually just set it to one column layout here. It's in this little hard to find disclosure menu with the lines on it. And then the only other thing after that is I like to create a console window and dock it to right next to the inspector here.
Yeah, I do that as well.
And that way we can access the console easily. It doesn't take up a whole lot of space and we don't need it, which is most of the time. And yeah, that's basically it. That's how you set up the scene. And so we've got scene and game are on the same window. I like this. If you have a big enough space to have both, that's great. But sometimes it actually even solves some problems, because sometimes you'll make some assumptions based on cameras viewing something, and it will count your editor cameras. So sometimes it's safer just to have the two only viewable one at a time. So here we are. We're in a big, scary new project with nothing in the scene.
It's been a while.
It has been a while since we've started with something like this. So, what are we going to do first? So let's just create something to have something. I'm just going to create a cube.
That's what I would do. And
we can double click and look at it, and yeah, it's a pretty cube. And if we go into the game view, we'll see that we have a cube. And it's at 0, 0, 0. I'm going to go ahead and move the camera down 1 because I hate that it's up 1. So now we should be looking directly at the cube.
Look at that.
And we're going to create a directional light just so that the cube has lighting in play mode. And I'm just going to move this up to 1,000 up.
Wow.
It will provide us light even though it's way far away, because it's a directional light. It doesn't matter where it is, it just matters what direction is pointed. And it affects all objects in the scene.
It doesn't disperse. It doesn't have a range to it.
Yeah. So we're going to hit play just to see how this looks, and yay, we have what looks like a square. So what we're going to be doing is we're going to be firing projectiles in a turn-based fashion at a target. And we're going to do kind of castle style here. And so we're going to play around with our physics systems here and kind of see what we can do with it. I think on the first day we're not going to have something that looks like the project that we're intending it to be. We're going to just start playing around with physics and get our hands dirty and see how things can be done.
Throw cubes at other cubes.
Yeah, we're going to throw some cubes at other cubes. Or maybe we're going to throw some spheres at other cubes.
Oh, that would be sweet.
Yeah, that would be wild. So,
what other shapes do we have? Capsules? Oh, we could throw
built-ins.
capsules.
We've got spheres, cubes, capsules, cylinders, planes, and quads.
I think we should throw capsules.
Okay, we'll consider that. Like this big old tube launcher.
Could be the spiritual successor to Dr. Mario.
Add a color coding system, so you have to hit certain parts of the castle and match the colors. I kind of like where that's going, but let's do one step at a time here.
Let's just start throwing
So
things.
let's start with some throwing. what's a good way to start with that? I'm going to go ahead and grab one of the built-in packages here. I'm going to grab the... I think it's in the scripts one. It's kind of generic sounding, but yeah, mouse orbit, smooth look at... Actually, I don't have anything I want here. Actually, I think I just want the first-person controller. So import package, character controller. I'm just going to hit import, and whatever we get, we get.
Yeah.
And we'll peel stuff out as we need it. It's just one of the built-in asset packs that comes with Unity. So, and we've used it a couple times before, mostly for our first-person shooter things. And we're going to basically set this up as kind of a first-person shooter to start. So I'm going to take a look at what we got on the first-person controller. So we have a mouse look script on there. So let's just attach a mouse look script to the camera. Where is it? Mouse look. Oh, sweet. It's already C# for us, too. That's nice of them.
That is very nice of them.
Some of them are not. That's okay, though. So if I attach this to it and I hit play, what do I get? Okay, I can look around. It's kind of hard because we only have one thing to look at. Cool. So it does work. We can mouse around and we can look around, so that'll be good for our purposes. I'm going to go ahead and make the sensitivity lower. I'm going to go with 5. And there we go. That's looking good. So now we have a cube and we can kind of look around. So let's now make it so we can shoot something. So I'm going to create a C# script. We're going to call it fire projectile. Now we're going to double click it and wait for mono develop to actually open. I usually open this and warm it up before the episode, but I did not this time for some reason. So
there it goes.
Hope everyone can hear me, right?
I hope so.
Yeah, me too.
If you can hear us.
Yeah, if you're having any technical issues,
leave a
let us
message
know.
if something weird is happening.
So, fire projectile. So we're going to need a couple of variables to start with. One of them we're going to need a projectile itself, so I'm going to create a public game object, and I'm going to call it projectile. So this is what we're going to use. This is the object that we're going to actually spawn and fire when we choose to fire. And we're going to apply a force to it, so let's do public float force. And let's give it a default value of, let's do 100.0f. Whoops, 0.0f. I said OF, but I actually meant 0f. So, what else are we going to need? We're going to take the angle of our viewing area for now, so we don't need to give it an angle or anything. I think this is actually all we really need.
Mm-hmm.
So, oh, we could have, I guess we could set up a input button. So public string fire button. We're going to default this to fire1, which this is one of the built-in, in the control scheme, fire1 is automatically defined to you on the control key, and I think it's also on the left click, so we can use either to actually fire.
I think that's correct.
So, don't need to do anything in the start here. Let's look at the update function. So, in our update function, we're going to check to see if you are pressing the button. So, if input.get button down, string button name, so we'll use fire button. So this will pass in our fire1 as the string. So if that button is pressed, then we are going to instantiate our projectile, and we're going to instantiate it at transform.position, which is the position of the object that's shooting, and the rotation I'm just going to use quaternion.identity because I don't actually care what direction is facing when you fire it.
No.
We may care about it if we do a capsule, so you might revisit this if that's a problem later. But that'll be fine for now. And then we're going to actually have to do something with this object to like apply a force to it afterwards. So so I'm actually going to change my declaration here. So we declared it as a game object. I'm actually going to declare it as a rigid body. This way, we won't try to apply a force to something that doesn't have a rigid body. And it also makes it so it's easier to get a rigid body reference from this. So since this is a rigid body, when we do rigid body instance equals instantiate as rigid body, instance will now already be set up for us to use. So now we can just do instance dot apply force. Wait, no. Dot add force. And so the force is going to be, the vector we're going to want is transform.forward. And we're going to multiply that by our force. And anything else we want to do here? We can change our force mode here. Actually, I'm going to make the force mode changeable in our editor. So I'm going to actually make it so that there's a public force mode force type. I guess force mode's fine. So we'll just pass in our force mode here. This will allow us to change things around as we need.
Cool.
So back to our project here. We'll see if we got any compile errors. It looks like we're good. And I'm just going to attach fire projectile to our main camera. So now we have this projectile here, and so we have our force mode. So we've got force, impulse, velocity change, and acceleration. We have our force, and we have our projectile that currently has nothing attached to it. So if we hit play right now and then attempt to fire, you'll get this unassigned reference exception down here.
Mm-hmm.
And we can go look at it in the console, and all it's basically telling us is that we don't have a reference to anything, so it doesn't know what to do. So let's fix that. We're going to create a sphere, and this is going to be our projectile. I'm going to go ahead and call it cannonball.
That's a good call.
And so we're going to need a prefab of this that we can instantiate. So when we drag this over into the project pane here, it creates a prefab. And so now you'll see this is turned blue, which means that if we make changes to this, it could change this as well, which is one of the features that's nice. So if you have a bunch of cannonballs, like if you had a bunch of enemies that needed to be of one type, you'd set them up here, and then you could create as many you wanted in the scene. And so, or you can instantiate them at runtime like we're going to. So I'm going to go ahead and delete the cannonball from our hierarchy here.
Because we don't need it anymore.
We don't need it anymore. And so what we're going to do is, so we have this reference. And so if I drag this in, we get a cannonball, basically. That's all this means. And so if I delete this here, go to our camera, we have our projectile here that's being referred to. I'm going to drag it in, and it's actually not going to work. And the reason is because we've decided to do rigid body instead of game object. If we had just done game object, this would have worked, but then it would have caused a runtime issue when you tried to fire it because you're trying to apply force to something that doesn't have a rigid body. So let's add that to it. So we're going to click on the cannonball here. We're going to go into the component, physics, rigid body. And we'll go ahead and have it use gravity, why not? And all of these settings seem fine for our purposes right now. So now if you go in here, it should drag in just fine. There we go.
Mm-hmm.
So if we hit play, I can now click, and
it just
throws up a sphere. Bleh. So 100 doesn't mean much in the force mode that we did. So the force mode we did is just basic force, which means that it's designed to be played over frames. It applies it to the object. It takes into account the mass of the object. It takes into account a lot of other things. And so typically, if we wanted a force of 100 to actually mean something, we'd be doing it over multiple frames. But we're doing just an instant thing here. So you can do impulse, and I think that'll fix it up a little bit, but it's still not going to be as good as we want. Oh, it helped a lot, actually.
Whoa.
More than I thought it was going to help it.
Yeah, that's a substantial amount.
Huh.
Wow.
Yeah. Okay, so you can see how these force modes really affect the abilities here of your what this number represents.
What do the other ones do?
So what these should mean is force takes everything into account. Impulse, it's where you apply the force entirely that one frame, and so it does still take mass into account and a few other things. Velocity change just literally changes the velocity to be 100. So like no matter how massive an object is, you could have this gigantic thing that says massive of like 3,000 units or something, and it will just be, well, now it's going 100 meters that way. And so this will look probably very similar to our impulse thing because our mass, I think, is 1. Yeah, looks very similar. I like that it actually hits and then kind of just doesn't bleed off any of that velocity at all.
No, it just goes around it.
Yeah, and acceleration... What is acceleration? I wonder. Let's see what it does. Oh, it just kind of throws it up again. I don't know what the difference is. You can look these up, I'm sure.
Go impulse.
You like impulse? I like
Yeah.
velocity change.
Well,
first
either
though.
one's fine.
Let's do velocity change, and let's change this down to like 50. See if we can get to the point where it kind of...
That's still crazy.
That's funny as heck. Let's make this a little bit bigger so we have a target here. So I'm going to scale the X and the Y, just some arbitrary amount. See what happens. There we go. Now it's actually stopping it.
Nice.
So we have the ability to make spheres and have them hurtle at things. So that's good. We're well on our way to what we want to make here. So let's play around more with physics. Let's actually build something to destroy. So we could do this the hard way, which I'm going to start doing it the hard way for a brief moment first. I'm going to make this into a little base for us. So
I might have some assets.
oh, you have assets. Where do these assets come from?
Remember my Ludum Dare game?
Oh, your city destroying game
Yeah.
thing? Yeah, actually, that's not a bad idea. I was planning on doing this with just cubes and
No, that's
stuff for
good.
now, but
I'll send it to you anyway.
so this will be our base for our little castle wall test, and put it down a little further. -5. Is that too far down? That's perfect. That'll be great. And let's start making... I'm going to make this a little bit wider so we can have more room to work with. And I'm just going to create another cube. And this one we're going to... I'm going to call this our base. I'm just going to rename it base. And we're going to take our cube here. And let's make it a little bit bigger. I'm going to make it 2 by... Yeah, we'll make it 2 units in every direction. And we're going to add a rigid body to it. Physics, rigid body. And so if we hit play here, we should see the cube fall and come to rest. There we go. So now if we hit it with the ball, you can see that the cube flies off into space, because we're hitting it with quite a bit of velocity and mass. So we have the workings of making a wall. All we need is more cubes. And we could do this manually. I might even just create a little stack just to show how that's done, even though that's probably pretty obvious. Where is this at? -5. Let's make this one -3.5. And we're going to just create a prefab of this. We're going to call this wall chunk. It's not very convincing, I know, but it's a wall chunk. And I'm going to go ahead and just duplicate, just Command D or Control D if you're on Windows, and we're just going to make a little stack of these. So if we hit play, we should have a little stack. Looks convincingly like a wall.
Yeah, it does.
But if you hit it, it breaks into pieces. So that's good. Now we could, make these and then duplicate them the other way and kind of make a wall thing going on here. But we'd have to, line everything up, and it would work. It wouldn't be a big issue to do it this way. But I'm going to write a script that actually spawns these in the way that we want. We've done something similar to this on previous episodes, but it's a new set, so we're going to do it again. I actually like redoing scripts because then the scripts are always up to date. Obviously, you want scripts to last as long as you can. You want to update them when you can, but for the purposes of the show, I like to kind of show how to make something, and then also it means that I get to revisit these things and figure out how I'm going to remake them differently. Sometimes if you just start from the ground up, you'll realize that you have a lot to unlearn that you've learned on previous projects on your new project. So let's call this spawn wall is what I'm going to call
What
it.
format do you pick these things in? FBX?
Yeah, FBX is usually preferred.
I don't remember much about this.
You have like city stuff that you're going to blow up. That's awesome. I'm down with that. We may have assets.
Yeah, they won't have textures with them right now.
Okay. That's okay. The cubes would get all upset if we had textures on everything.
That's true.
Alright, so I'm going to save the project. What are we going to call this? This level is just going to be called wall test is what I'm going to call it. And so we're looking at the spawn wall code here. I just double clicked the spawn wall thing and it brought me in here. And what I'm going to create is, we'll assume that the wall is standing vertically. We're just going to make some assumptions here. And so we just care about the X and the Y amounts, and then the Z depth will not have a depth to it yet. We may add one later. So public float, actually public int, let's see, width, we'll default this to 10, public int height, height equals 10, and public, I'm going to go with game object on this one.
I think you have your building now.
Alright, cool.
But yes, continue.
Yeah, I'll see if getting that in a bit here. I don't really have my email open or anything right now.
No worries.
Public game object, wall chunk. Doesn't have to be called wall chunk, but it's gonna be called wall chunk here. So this will do is just build a wall out of smaller pieces. So in the start, we'll actually spawn the wall. So for x equals, so for integer x equals 0, x is less than width.
Yeah.
And x plus plus. So this is a for loop. What this means is it will be looping through this while x is less than width, and at the end of the loop it increments x by 1. That's what the x plus plus means. So this basically just says we have an x is equal to 0. Every time if it's less than width, we continue doing this loop, and then we add 1 to x. So eventually, after 10, theoretically, this will go away.
Oh yeah, it'll get from 0 to 9.
And so we'll do the same thing. We're going to do an embedded one here. Actually, let's just do this one so the people see this first. All right, so we're just going to do the left to right first. So, what we're going to do is we're going to instantiate, and we're going to instantiate the wall chunk, and the vector3 position is going to be transform.position to start. And quaternion rotation, we're going to just do quaternion.identity again. That means that we don't particularly care. The identity of this thing will be facing some direction, and all of them will be facing the same direction, and that'll look good enough. Mm-hmm. And we don't have to do anything with this at this point. So if we just were to run this, I'm just going to go ahead and show what happens here. I'm going to attach this to, we're going to create a new, I'm going to create an empty game object. Call this wall spawner. And we're going to put spawn wall on here. And I'm going to position it about there. And we're going to attach the spawn wall to it. And we're going to give it our wall chunk as a chunk.
So 2 spawn wall. groups.
Oh, okay. Thank you.
Mm-hmm.
Gonna remove one of those, and we're gonna put wall chunk on here. I don't know why it came up with 2. I must have done it twice somewhere. So we hit play, and you'll see that we have some cubes that kind of flew off into nowhere. It's kind of lucky to even see them. And the reason being is they're actually all spawning in the same location right now. Because all this is doing is it's saying, oh, spawn this at my position.
Spawn 10 of them in the exact same spot.
So it's spawning all 10 of them in the same position, and then they're all like, oh my god, we're inside of each other. And then they force each other out, because that's what rigid bodies do when they suddenly panic and realize that they're touching other things. So so we need to fix this. Really easy. We just need to add an offset to this spawn position appropriately. One of the things that we're going to need to know, though, is kind of how big the object is we're spawning. So I'm going to actually grab that information from the object itself. So let's go ahead and create a private variable to store this. So we're going to do private float chunk width, private float chunk height. You're thinking about Chunk from Goonies, aren't you?
Yeah, I am. I can't stop thinking about the Truffle Shuffle.
Yeah, it happens.
Yeah.
I've been working with Minecraft, and they do all sorts of chunk loading and chunk weighting and chunk this, chunk that, and I've got Chunk on the brain now.
Yeah, Sloth love Chunk.
So, no one in our audience actually has watched those movies.
No,
I don't
probably
think.
not.
Probably not.
Probably not.
We're old people now.
Yeah.
So, chunk width. So, we're going to find that out at the start. We're going to take our, so chunk width equals wall chunk dot scale dot transform dot scale. So, we're going to use the local scale on it. And dot x. So, that'll give us our width. And then we're going to just do the same thing, except for it's going to be chunk height. And we're going to do wall chunk.transform.localscale.y. So this is our width and height. And so now we can actually adjust things appropriately. So we're going to transform.position plus transform.right times chunk width. And so what this will do, oh wait, and we need to do one more thing. So this is just going to offset it by 1 always. We want to multiply all of this by our x, which is this
which is
this
the variable
x right here, the int x. So now it should spawn them each in their own little position when we hit play here. There we go.
Yep, there they are.
There they are. And you can see that they are actually still individual elements, but they spawned in a nice row, and they look like they're one contiguous thing. That's always fun.
And they actually landed all on the platform.
Yeah, that was
pretty amazing.
I wasn't expecting that. I was expecting one of them to slide off or something,
typically
but no,
that's
we
what'll
got it.
happen.
So we have the left right done. So now we just need to do the top to bottom. So let's create another for loop here. For int y equals 0. Y is less than height. Y plus plus. Alright. So I already kind of know what we're going to be doing with this, which is why I'm encapsulating the instantiate. So now we have an x and a y, and we have to determine where to spawn it. And so what will happen is the y will increment up to 10, and then the x will increment by 1. It doesn't actually matter which way you do it. You could do it x, y. You could do the y's here and the x's there, whatever makes you think about it better. But what we're doing right now is we're going to do basically the far left one, create a column, next one over, create a column, next one over, create a column. So, and now we just need to actually create those columns. So if so we want to do transform.right times chunk width. And then we're also going to add, so we've got our transform position, which is the initial position, right? We're adding our x times the right transform, which is a 1 unit vector 3 that represents to the right, and we're multiplying that by our chunk width, which represents our horizontal distance between things.
Mm-hmm.
And so now we're going to do the same thing. We're going to just add another plus here. And this one's going to be
y
times transform.up times chunk height. And so now, when we hit play, we have a wall.
Whoa, that's...
kind of...
Whoa.
Physics are freaking out a little bit. Okay, but it's
shoot
there.
It.
It's
Just
there.
shoot it.
Boom! It looks awesome. See, it's working. So this is our basic concept for how the walls will come crumbling down.
Now just to prove a point that's kind of interesting, if you change the shape of those a little bit, those prefabs, so they're not exactly 1 by 1 by 1, it should still work.
Yeah, well, they're right now 2 by 2 by 2. But,
okay.
But yeah, so if we change the wall chunk, we could make them larger. Let's make them 3 by 3 by 3. It should still operate because it takes into account the size. So
or
you
even
can see
odd
that they
shapes
are
too.
still there. Odd shapes, will
they'll do their
potentially.
own thing.
Yeah. So like, let's try this. Let's do 2 wide. Let's try to make it more brick-like and 1.
And Z3. Yeah, that seems good.
Let's do that.
Yeah.
So now we have kind of the. There we
Whoa.
go. We have more of a brick thing. So what's happening there is the whole thing's dropping in, right? So if we could fix that just by changing our position of our wall spawner to actually be closer to where we're trying to put it. So if we set this to negative, so where's this? -5. So what's the appropriate one? It's 3.5, I think. 3.5 because they're 2. Oh wait, no, you're right. 4.5. 0.5. So
now this should just be. Well, let's see what happens.
That's not going to work, actually.
It'll probably just throw it up a little bit.
Let's try 4. Hit play. There. Worked out nicely. Now, you can still see that there's some...
There's a little bit of
sway going on. Not
That's
entirely sure
probably
why.
just the rigid bodies interacting exactly with each other. Like, because they're right next to each other. Like, if you maybe put a little bit of an offset, it probably wouldn't happen like that.
Yeah, we could probably... get away with this a little bit too by actually setting them up to be let's see what's going on with this. It's funny that they're actually moving just a little bit.
It's very slightly swaying. I just think they're very mildly fighting. They're not incredibly happy.
They must
with
be
each
just
other.
slightly interpenetrated in some way. We could put a little here. Let's test something. Let's put just a tiny little offset. Let's do a public float offset equals 0.001.
Yeah.
F.
Very, very slight.
And so we'll just add this
right inside the
plus
params,
offset.
Right?
And then plus offset.
So you're going to see him fall just very slightly at the beginning, probably.
Yeah.
Very, very slightly. Oh, what?
What do I do?
Didn't like float.
Plus offset.
What was the error exactly?
Alright, so operator plus cannot be used between operands of type Unity, Engine, Vector 3, and Float. And I agree with that. But I didn't think I was asking it that.
Why does it do that?
Hold on. Let me just kill that thing for right now. I'm going to have to add this to... Alright. So, interesting. So, X times... Oh, yeah. It's because it's doing order of operations the way that it's supposed to be doing it.
Yeah, it's order of operations issue.
So what was happening is it's totally okay to multiply a vector by a float, but it's not okay to add a float to a vector. And so it was multiplying by this float, and then it was trying to add this offset afterwards, which is a float. And so it doesn't work that way.
It still doesn't like it. No.
Position.x plus...
Additionally, what you could use is...
Oh, I didn't save.
Oh.
Simple enough. Alright. Yeah, it doesn't really solve anything.
No, but it did put a little bit of gap.
Yeah, let's get rid of the offset. I don't like the offset.
Okay.
these extra braces anymore. Do we have any questions or any comments in the
I have not seen any
information yet?
Nope.
All right. People can hear us though. That's good.
Yes.
And someone sent a question on the Twitter though.
Oh, really?
Yeah.
What did they say on the Twitter?
When is it appropriate to use transform.translate rather than... Hold on, pulling up my Twitter. Transform.translate in place of transform.position plus equals. I actually don't think there's a difference. So use whatever you prefer. I prefer actually changing the value of transform directly. It does make a difference potentially when you're working with rigid bodies. If you want to move a rigid body, you should use rigid body dot. Is it rigid body dot move?
Is it?
Let me see.
I can't remember. I'm
just
sorry.
create a real quick rigid body test dot move position. Yeah. So if you want to maintain collisions between rigid bodies, move position is safer than just changing the transform. A lot of times, if you just change the transform, it does still work, but that one is actually different than just changing the position directly.
Well, yeah, if you just change the transform on a rigid body, it can easily interpenetrate with a wall.
Yeah, you can push things through places where you wouldn't expect to be able to push them through.
Whereas the move will take into account.
It should get collision information, hopefully. Sometimes, when you're working with this stuff, a lot of times you just have to kind of play with things until they work right. So, but yeah, that's one that might save you some headaches later. But yeah, I don't think there's any actual difference between doing translate and just actually doing plus equals your new position. So let's actually make it so that it doesn't do this though. Let's get rid of the listing. So we can do that by actually. I'm going to change this again to a rigid body. So we're going to use a rigid body reference instead. And so we're going to do a rigid body instance equals instantiate, and then we have to cast it as rigid body. So now we have a reference to the block that we just created, and I'm going to just quickly oh yeah, this is going to be a little bit more complicated than I wanted. Yeah, whatever, this will be fine. So I'm also going to so my plan was I was going to set them all up so that they do not have, so that they're all set as kinematic, which should make them stay still, and then I was going to unset them as kinematic, which might have solved the problem. Let's actually see if that'll work in a test case real quick before I go to the trouble of doing this. So we've changed them to rigid body, so I probably have to oh no, it was, did it? No. No, it lied to me.
It says spawn wall doesn't exist anymore.
Oh, variable wall chunk doesn't exist anymore. It does though, but
that's
okay, so that's fine. Let's remove this component and then add it again. All right, there we go. And now let's throw our wall chunk in here because it already has a rigid body. It's done, and we're going to set all of these to is kinematic, and we're gonna hit play, and we should have nothing moving. Yeah.
And even if you shoot it, I don't think.
Yeah, if I shoot it, nothing will. Yeah, just hits it like it's a brick wall. So if we're in here though, and we take our wall chunks, and we select all of them, and we do is kinematic off, we'll see if they start. Oh no, they do immediately start.
Yeah, they immediately start moving.
Interesting. Oh well. We may have to get fancier on things then. So let's that's not going to fix it then. That makes me very sad. Alright, let's look at our wall chunk again. Turn off the kinematic. And we're using a box collider, okay. Does it have the problem if we're all one unit? I'm just curious. Yeah, still has the problem.
I find it interesting if they sway slightly.
Yeah, I kind of just expected them to be close enough that it was just going to be like, oh, that's perfect, and call it good.
They do destroy pretty cool, though.
Yeah, no, I'm liking what we got so far.
You know what I recommend doing?
What? What do you recommend doing?
Putting the height up to 50.
Okay. All right. Why not?
Yeah.
Height, 50.
Yeah, sure. Go big.
Oh. There we go.
Oh, wow.
There's our buckling,
Holy.
crazy. Oh, it's falling, it's falling.
That's awesome.
Computers are so awesome these days.
Yeah.
I just love that you can just be like, oh yeah, just do physics on all of it, whatever, who cares?
Yeah, physics on all of it.
And stream it on the internet at the same time.
Make
do
it
like a
100
video
if you
thing.
want to.
Yeah.
Okay.
Now there is a point where it will start to kill
yeah.
things, so yeah, you don't want to set these to like 1,000 and 1,000. You will very, very quickly regret that decision.
But 100 would probably be okay.
100 probably is doable on modern hardware. You probably couldn't do that on a mobile application, but you could do that on anything you're making for PC. Here, let's check 100 and 100.
Oh, wow.
Why not?
Oh, God.
There it goes, and it's running real slow, and they're doing all of their collision checks, and it's horrible, and I'm going to hit play again before I don't be able to do anything.
Yeah, that's terrifying.
No. Stop playing. There we go.
Wow.
Yeah, let's not do that again.
Yeah, no.
So, let's go 10. Actually, let's do 20 by 10.
Yeah, like that. Yeah, it's really buckling. Look at that. So much so that it's falling down.
Well, that one is kind of on the edge there.
Yeah, well, that's its own fault.
Okay, let's make the base a little bit bigger. 30.
Yeah. What happens if you move it down a little bit more? It seems like it's slightly falling. Very, very, very small amounts. It should be about right on, though.
If we move the whole thing down, the spawner a little bit down.
No. Yeah, the spawner down just slightly. Like if you go to 3.75.
So, wait, further down? Or
Yeah.
So that would be 4.25
Oh,
like
4.25.
or something?
Sorry about that.
No problem. We're in the negatives. It's...
Yeah. No, that didn't help anything, did it?
Actually, it might have been closer. Here, what are we looking at for the bottom chunks here?
It's...
Okay,
for some reason about
4.0.2.
4.0.2. That's odd. Wonder why it's slightly lower than 4.
That's probably just it's being pushed in by the things that are weighing above it.
Oh.
Yeah, it's probably just doing a little bit of interpenetration because of the fact that it has all that resting rate, and so it's just like apply force, and then eventually you get down and it's inside of it, and that's the reason we're getting the listing.
Yeah.
So so let's see what we can do about that from a gameplay perspective to make this work, so that we have what the resemblance of a solid wall, but without having it feel like it's going to just fall at any moment. We want it to feel like it's a really secure wall, and then we're hitting it hard and then blowing pieces off of it.
Yeah.
So let's actually go ahead and do the let's start them as kinematic and hit play. And so now they are really solid wall. So how can we make it so that these things become non-kinematic in an interesting way? So I'm going to make it so that these
Like
are the
when
kind
they
of
get a
tricks that you have to
collision.
do. So I'm going to take a cannonball and bring it in so that we can work on it a little bit. So here's our wonderful cannonball. And I am going to...
Oh, I got a suggestion. What if you staggered them like bricks?
It probably won't fix the problem, but let's actually go ahead and add a stagger, because I think we might want it to look like bricks at some point.
Yeah,
so let's
that's
actually
cool.
give that a shot first to see what happens. We'll get back to this cannonball thing in a second. So let's make it so every other line we add an offset. So we'll do we'll make the stagger based on half the width. So we'll just do what's the easiest way to just do every other one? Okay, so we're gonna make
you can do a modulus.
Yeah, that's what I was gonna do. We're gonna do a float stagger offset, and we're gonna set it to 0.0f, and then if y modulo 2, do it like that, equals 0. So modulo is
essentially the remainder.
Yes, the remainder. So if you remember log division, which I don't think anyone does, but if you do,
I remember.
You can basically divide things, and then you have a remainder left over, and then you can do more math to get the actual decimal places after that. But the first time you learn it, you learn about remainders, and you just like, what's the remainder of this? So this just returns the remainder. So modulo 2 means that if it's 0, this will be 0. If it's 1, it'll be 1. If it's 2, it'll be 0. If it's 3, it'll be 1. So on and so forth. So every time that it's divisible by 2, it will result in a 0, and then we will do whatever we're doing here. So what we're going to do is we're going to set stagger offset plus equals, just equals the chunk width divided by 2.0f. So now if we just throw the stagger offset here into the x portion of our equation.
Do you want an else in there as well?
No, we don't need it, because it's going to be 0, otherwise it's already set to 0 up here.
Oh, okay.
So,
sorry.
Hey, you don't have to apologize. No, I'm glad you're asking these questions. That you could have done it as an if-else and just have stagger offset and then set it to 0 explicitly. It doesn't matter either way. So we want times chunk width, and then we want to also offset. So we want the offset to be chunk width. I want the whole thing to be offset.
Yeah.
Okay, so I don't want to actually add it in there. Let's do one more addition thing here. Plus transform dot right times stagger offset. We probably could have stuck it in there somewhere, but I'm just going to do another addition. It's not going to hurt us too much on the calculation. There we go. We have our nice staggered pattern. And actually, oh wait, no, they're all set to kinematic right now. I was like, it fixed it!
Yeah, I thought it did too for a second there.
So let's hit play. Yeah, it still unfortunately has this problem.
One just fell off the top.
Well, yeah. Well, that's because it was hanging off a little bit. But certainly feels a lot more wall-like. That's actually really cool.
Yeah, that is. It's like
definitely going to be keeping that.
Yeah, I like that offset. That's cool. That is cool.
All right, so but we want it to actually look like things are going well for the wall before we hit it. And see, now things are going really well for the wall, too well. So what we're going to do is I'm going to open up this cannonball.
What if you added more mass to the wall?
That's going to probably make it sag more, honestly.
You just think it'll make it sag more?
I do. So what I'm going to do is I'm going to create a collider around the sphere. So we're going to create a empty game object, and I'm going to child this real quick. So cannonball, and so this game object, we want the cannonball to be at 0, 0, 0. Okay, it already is. Perfect. Sometimes Unity does things exactly the way I want it to. It's weird. So I'm going to call this the cannonball, and then we're going to call this the cannonball
object.
Yeah, sure. Cannonball ball.
Just render. That's actually the game
mesh. We could call it a mesh. Yeah, we'll call it a mesh, even though it also has some game object stuff on it too.
Well,
And then we're going to create another. I'm going to just create another sphere here, and we're going to put this in here as well. And this one we're going to call
Cannonball collision.
anti-kinematic field. Why not? Let's just call it something weird.
AK field.
Yeah, the AK field. So we don't need this thing to actually look like anything. So I'm going to remove the mesh filter and the mesh renderer, and we're going to keep the sphere collider, and we're going to call it a trigger.
You gotta get this.
And I'm going to make this bigger. We're going to make it like 5 by
Holy
5 by 5.
That is quite the AK field.
Yeah. And what we're going to do is we're going to create a C# script called disable kinematic on trigger. And we're going to double click it and write something in here. So I'm going to get rid of our start and update because we don't need those, and we're going to create a function called void on trigger enter. So this is actually one of the built-in Unity fun functions that we're actually overriding, and this gets called anytime that this object is considered triggering with something else, and it gets a collider as a reference. So we're going to, on anything that is collided, we are going to say if col.rigid body. So if the thing that we've collided with has a rigid body, then we are going to set col.rigidbody.isKinematic to false. Wait, is that how this works? I don't think that's how this works. Is kinematic equals false?
Yeah.
And so this will just do that to anything that it finds that has a rigid body, which will probably include our ball, but we don't care too much about that at the moment. Let's just see if this will work. So,
is it kinematic right now?
The balls shouldn't be. I mean, we're
Yeah.
applying forces to it, so. We're going to add this to our anti-kinematic field. And so now if we hit play... Well, who cares about that ball? Oh, wait, we might care about that ball because I don't think we've actually applied it to our prefab yet. So I'm going to create a new cannonball here. We're going to get rid of the old one. Going to rename this to cannonball. Delete the one in the scene. And we're going to go back to our main camera and set the new reference, which is now missing. And we're going to set it to... Oh, we can't do that because it wants a rigid body. And this top parent doesn't have the rigid body.
Why don't you just have the cannonball mesh be the parent to the anti-kinematic field?
Well, because then the way things work is a little bit different. I think we may want to do that anyway. Here, let's try it. All right, so we're gonna try what you suggested. So what Phil suggested was we actually just make the anti-kinematic field a child of the cannonball itself, and we don't worry about the cannonball parent at all.
Okay.
I have a feeling this is going to cause us a problem, but I could be wrong. Because it may consider this outside area part of its collider now. Because it does a compound collider thing for hierarchy.
Well, let's see what happens.
Let's give it a shot. I'm going to keep that old one there just in case. So we're going to go back to our main camera. We're going to put our
Cannonball
cannonball mesh into here.
Delete the old cannonball.
Yeah, get rid of this one, hit delete, and hit play. And now we're going to shoot. Looks like it works exactly the way we wanted it to, actually. So you can see now that the wall is actually... Now the problem with this, of course, is if we knock things out here, maybe it's not a problem at all.
Well, there's not a difficult fix
problems
for it. But you could do a raycast down and find out if it has anything below.
Yeah,
it,
we
and
may
turn
have to
on
do that.
kinematic.
We're just feeling things through right now.
Yeah. Kind of like it.
So, like, if I clear enough of this, you'll see that the things above just kind of float. Because they're actually still kinematic, and they're just like, hey, we're fine.
We're
I haven't seen
kinematic.
anything.
I don't know what your problem is. Oh, God. Yeah.
So as soon as we shoot a ball near it,
That's kind of interesting.
Because they're basically that sphere of influence is changing the objects to be kinematic.
It's kind of cool how it dents, though.
Yeah, no, I do like that. Let's actually make our ball a little bit... all right, I'm going to go with it. I'm going to delete this because that seemed to be working just fine. I'm going to change this to be called Cannonball. And let's make them so that they're a little bit more massive. Let's make them 100 mass.
Oh, I bet
Let's
they
see
aren't
what
going to fly
happens.
nearly as fast anymore. Oh, they will.
They should fly exactly the same speed, but they
Whoa.
certainly go through a lot better.
That one actually... They were going through
Kind of
too
stretched
well.
through too well. Yeah, all right. So let's do 10.
Oh. Now that is more what I'm expecting. That's still maybe a little too well.
I kind of like it.
Definitely has more power.
So how are we going to fix the floaty problem in this proposed system?
I do a raycast down.
Yeah, but like, so would it be after it can't find one within a certain range, or
Yeah.
would it be... Okay.
Yeah, once the raycast, basically the raycast would project down like maybe one unit, so it knows if its direct descendant is still there or not. And then if it detects that there's nothing there, if the raycast hits nothing, then you can just turn on the turn off kinematic, and it starts falling, and things should.
Let's do that for our last thing of the evening then.
Okay.
So
That's what I ended up doing in that LD.
Yeah. So we're gonna do disable kinematic on failed raycast.
Yeah.
Yeah, let's give it a shot. That's a weird name for something, but whatever.
Just invoke it every.
Yeah, so what we're going to do is, this is going to be on each of our cubes. And we'll just use the cube's size to determine how far it should raycast down.
Oh, that's good idea.
And so in our update, we're just going to do a... so what a raycast is basically just checks to see if there's something in a direction. And so... raycast physics raycast. I'm just gonna see what we're looking at here. It takes array, it takes distance, it takes origin and direction.
Like origin and direction.
Origin, direction, distance is probably
That's perfect.
what we need.
About
to
perfect.
work. So transform dot position.
Right.
The
down.
we'll do so wait, what are the options? Origin, direction. Okay, so direction would be transform dot down. Okay, there is no transform dot down, so transform dot up. So negative transform dot up. That's our down now.
Yeah, well, that's exactly what it is.
Yep, it is. And we didn't want we want the one with the distance, so we can just throw a distance here. So we'll do the distance being transform dot scale. We'll do local scale dot y, and we need that.
And print.
So this will return if there's actually a successful raycast. So we'll encase this in an if statement. Get rid of this semicolon. And replace it with nice curly braces that we can do stuff with. And what are we doing? Transformed opposition, transformed up. Actually, I'm going to do half the local scale.
Okay.
2.0 F, because we're already projecting from inside of it anyway. No, let's do the whole thing.
Okay.
We can adjust it more later. So if that happens, then we'll set our rigid body dot is kinematic equals false.
So that's if it hits something?
So if... Oh, yeah. So if it hits something, then we don't want to do this. It's only if it doesn't hit something.
Well, we actually, just...
Else. I guess we could put a not there.
Yeah.
Yeah.
Yeah, we'll do... Yeah, that's a good call.
If we don't raycast successfully, then we will set our rigid body. So if we hit play now...
Oh, we need to...
we didn't actually put it on the bricks. So we throw this on our wall chunk and hit play. And it looks like things are going okay. So we hit the wall here.
And again.
And I'm just going to start knocking things down.
There goes. Well, so it's working, and the problem, it looks like, is it's still detecting it. Well, let's see.
It also might be that it's not coming out of sleep.
Yeah, there we are. Yeah, it's...
Okay, so the problem is it's not coming out of sleep. So let's fix that. Rigid body dot sleep is sleeping.
Was false.
That's a function. We can't just set that one. Wake up. There we go. Rigid body dot wake up. Wake up.
Wake up, rigid body.
So now let's see how this does. Looking better.
Yep, there we are. That's kind of neat.
That's kind of really cool, actually.
Yeah, the raycast down thing works pretty well.
I call that success.
Yeah.
I think that's what we're gonna go with. So we solved a couple problems. We played around with some physics, and I think we had a good time.
Yeah.
And so this will be a good starting point to actually start building some logic and some level around afterwards. But this at least shows us their proof of concept. This is what we'd call a proof of concept in the games industry.
Yeah.
This is our wall concept for our game. So, and it appears to be working, and so now we can do other things with it.
There is a question.
Okay.
From The Dark Dragon 91.
All right.
I'm curious on how you plan to do the turn-based code. How much of the code do you think will be usable as a base for everything that would use turn-based gameplay and code that is just for this?
Well, I would imagine that it would be quite usable by any game that has a two-player turn-based mode. We're just going to be focusing on two-player for this one, and I would imagine that you could use it for probably pretty much anything.
Yeah.
We probably will throw some game-specific stuff in there, but just keep in mind when you're playing around with it, if you're looking to make this into something else, always be diligent on trying to figure out what we're doing, and yeah. So I'm going to say tentatively yes, it will be very useful in other turn-based projects. So
yeah, all code is potentially portable.
Yes. So that wraps us up for today. That felt really short because we're doing new stuff.
Yeah, it really did.
So, actually, let me save this real quick. Save.
Sounds like a good plan.
Yeah. All right. So, thank you very much for joining us tonight. If you have any questions, comments, or concerns, please email me at pushypixels@pushypixels.com. You can also tweet me at Drakfire, DRAKFYRE. And you should buy Phil's game Robot Alone on iOS. It's awesome.
No, thank you. You can send me emails if you want to. That's philip@protosoftworks.com. Or you can follow me on Twitter, and that's at Magmalemur. That's MAGMALEMUR on the Twitter. And donate to Cooking with Unity. There's a little donate button somewhere on YouTube that that you can press.
I still didn't bring that thing in.
And donate.
I didn't bring in the swag. We've got tile. Well, we've got example tile. I'm sorry I haven't sent out the swag yet for people. And then also, so the keychains should all be out, at least to the people that I had address information. I've been pinging people elsewhere. If you feel that you should have gotten keychains and you have not yet received keychains, please email me at pushypixels@pushypixels.com and let me know what's going on, and I will make sure that things get fixed up for you. So they should be at their destinations by now. It's been weeks, so I'm hoping that all went through okay. So again, if you felt that you have donated and you were expecting a keychain and have not received one yet, send me an email.
Also, thank you for our live viewers.
Yes, thank you for joining us
appreciate
live. Really appreciate it. I'm glad that YouTube allowed us to make comments, even though we don't have Google Plus installed right now. I don't know what the deal was with that earlier in the week, but evidently there were some problems with that. I had one case. It's not even worth describing.
Additionally, if you do want to join us live on the show, typically starts at 8:30 p.m. Pacific Standard Time. On Mondays.
Yeah, sometimes we're a little bit later. It depends on what our working day is like. So
we both do the work thing.
Yep. Thankfully, I have a job now. By
Yes.
the way, I'm not sure. I don't think I properly said, "Yay, I have a job!" But yay, I have a job. So yeah, and Phil has a job. Yay!
Yeah.
Jobs are wonderful.
I like being employed.
So thank you very much for joining us, and you guys have a great night.
Have a good night.
And we'll just let it run for a little bit.
Okay. That was fun.
Yeah. So PS3 or PS4, PS whatever,
It's a thing
PS
that's
next.
happening this week.
Yeah.
It's happening this week.
Yeah.
Now we're dating the show.
Yeah. Well, there's. I guess no, we don't do the numbers or anything anymore. So
No.
we're already
No.
dating the show by just whatever version of Unity it is. So
Oh, I guess that's a good
we'll
point.
always have whatever that is. So
Uh,
someone will be like, "Oh, that's definitely Unity 4.2.2." There's no question.
no question
you know.
about that. Yeah.
But
No,
yeah,
I like falling bricks. Apparently, I don't know why I like falling bricks so much.
no,
but I really do.
it looks good. I'm glad that was less painful than I thought it was going to be to set up. Actually, so that was
I like
nice.
the staggering.
Yeah,
It's pretty good.
Yeah,
I'm a fan of the staggering.
no, I'm pretty happy with how that turned out entirely. So
Yeah. Yep, it's gonna be good times. Good.
yeah, next time we'll actually maybe have some actual turn-based stuff in there.
Yeah, I think that's a good thing to shoot for next episode.
Yep. Anyway,
We're gonna do a little foreshadowing for the next one.
yeah. Might actually even set it up earlier.
Sweet.
I'm always afraid of setting it up for 8:30 just because we might be like, hey, yeah, I'm working till 8:30.
Yeah, well, typically we are
Yeah.
at 8:30. So
Anyway, thank you very much, you guys. You guys have a great night.
yeah, have a good one
Again.
again. Yes.